We're now looking at the teaching video on polynomials, particularly solving cubic equations. So we'll bring you through step by step on how to solve a cubic equation. Step 1, we'll look at let fx be equals to the cubic expression. The cubic equation expression that we're looking at is this particular part. So that will be the cubic expression. So first step, let fx be the expression. Well, the reason we let fx be equal to the cubic expression is that we will use the factor theorem in order to work out what values of x that we can put into fx in order to get fx equals to a 0. So when we get a 0 result, what it means is that this x value is a valid x value to obtain the factor of fx. So now we look at how to find a factor for fx. There are two ways to do that. Method 1, we use factor theorem, and this sets the place for it. So to do that, we have to focus on the constant here. So we think of all the factors of 36. So you can have plus minus 1, plus minus 2, plus minus 3, plus minus 4, plus minus 9, plus minus 12, plus minus 18, plus minus 36. And we can go into a certain trial and error by putting in some of these factors of 36 into fx to see if this will give you a 0. So for the purpose of shortening the trial and error, I will just use the calculator to get one x value that works. So 4 works. So if I put in 4 into the x, 2 times 4 cubed minus 11 times 4 squared plus 3 times 4 plus 36. So 2 times 64 minus 11 times 16 plus 12 plus 36 gives me a 0. Now, if f bracket 4 equals to 0, what it means is that if I work backwards, this is the x value I use And if I transpose the 4 to the left-hand side, I have x minus 4 equals to 0. So this is how I get the first factor. So I conclude x minus 4 is a factor of fx. So that is using the factor theorem. Now, what I have not mentioned also is that I can use the calculator to work out the value of x that I should put in. In fact, I did it just like that to shorten the process. But this is the written work that I must show, that I actually substituted the x equals to 4 into the f of x to obtain a final result of 0, and concluding that this is one of the factors of fx. Step 3, we are looking at two methods to get two other factors of fx. When we look at cubic equation, x to the power 3 tells us that there are at most 3 solutions of x. So if I have found one, then possibly there are 2 other factors as well. So long division is one way to do it. Of course, we can also use the polynomial identities. So what I do over here is to run through the long division. I have a divisor here, x minus 4. And the cubic expression. So the whole purpose is to get rid of the first term in the cubic expression. So x times 2x squared. I'll get 2x cubed minus 4 times 2x squared will give me negative 8x squared. So I take the expression at the top minus the expression at the bottom. So I get negative 3x cubed squared plus 3x. Now to get rid of the first term here, I need to multiply to x negative 3x. Then I will have negative 3x squared. Then negative 3x multiplied to negative 4, I get positive 12x. So over here, I take the top expression minus the bottom. I will have negative 9x, and I transpose the 36 to this position. So multiply negative 9 to x again, negative 9x. Negative 9 times x, negative 9x. Negative 9 times negative 4 is a positive 36. I get a remainder of 0. So this is a quadratic expression, and I can see there are 2 factors in it. Or the other way, this is one way, the other way is by polynomial identities. So what it means is that, I'll continue here. If I have 2x cubed minus 11x squared plus 3x plus 36, I can make it into a certain identity with x minus 4, the divisor, and I need a quadratic expression, ax squared plus bx plus c. Now if you look at this, I can take this as the dividend, and this as my divisor, and this as the quotient. So if x minus 4 is a factor of fx, then there shouldn't be a remainder. So in English statement, it will be dividend equals divisor times quotient. So I would need to solve for a, b, and c. Of course, that expression is obtained in the long division simply here. But for this case, if we exercise polynomial identities, then I need to do comparison of two terms, one on the left hand side and one on the right hand side of the identities. So comparing the x cubed terms, I have on the left hand side 2x cubed, and on the right hand side the only way I can get an x cubed term would be to take x multiplied to ax squared. I get ax cubed, and therefore I found the first unknown a, which is just 2. So next is to compare the constant term. So comparing the constant on the left hand side of the identity, I have 36. On the right hand side, I simply take the constant term in the first set of bracket multiply to the constant term in the second set of bracket, and I have negative 4c. Therefore, c is equal to negative 9. So then I have to focus on finding the value for b. So I can just compare the x squared terms. So on the left hand side of the identity, I have negative 11x squared, and on the right hand side I can obtain x squared terms simply by doing this, minus 4 times ax squared. So I have minus 4 times the 2 is negative 8x squared. And then another way to do that is the x term multiplied to the x term, x times bx. So that would be plus bx squared. So to take away all the x squared, I have minus 11 minus 8 plus b. So b will be negative 3. So you can see the 2x cubed minus 11x squared plus 3x plus 36 is actually equals to x minus 4 times the a is found 2x squared, and the b is negative 3x, and the c is negative 9. So by factorizing this, I can get all 3 factors These are the three factors. Now, let's go back to the start there. After step 3, I have the step 4. So step 4 is to actually solve for the values of x when f bracket x is equal to 0. So here we have worked out that the cubic expression is equal to the three factors here. So I will work out the answer over here. Now, looking at step 4, solve f of x equals to 0. So the f of x is actually 2x cubed minus 11x squared plus 3x plus 36 equals to 0. And we had the first factor over here, which is x minus 4. Using either long division or the polynomial identities, we found two others. By equating each of these factors to a 0, I get three values of x. So we have gone through step 4. So step 5 will be to solve this particular question. You can see this expression is in terms of y. Therefore, I put it as f bracket y equals to 0. So to continue, I have these cubic equations to solve. But we should not solve this from scratch. It should be to build on what we have found from here. So the thing is to make connection of the two cubic equations to see how x is related to y. So the way to do it is to look at, first of all, the constant. You can get 36 and 36. And then to look at this. 6y, and you've got 3x there. So if I just put 3, then in the bracket, I must have 2y. That will make 6y. So if that's the case, I should be thinking of 2 times 2y cubed and see whether that works out. 3, this is y cubed, I get a y cubed. 2 cubed is 8, 8 times 2 is 16, so that matches. Next, I will have minus 11 times 2y squared. Now, 2 squared is 4, 4 times negative 11 is negative 44. So we have got matching pairs of cubic equation. So you can do a direct comparison. The x must be 2y. So in other words, I have 2y equals to 4, negative 1.5, or 3. So to solve for y, I simply would divide these values by 2. So y equals 2 or negative 3/4 or 1.5 will be the solution for this particular equation. You can see by linking the two cubic equations in such a way, I have avoided solving this cubic equation by going through all these steps again. So, since we have gone through all the steps for this, we must make use of the result here to obtain the value of y. So, in this video, we have brought you through the steps, and these are the 5 steps to solving the cubic equations. We have come to an end of this video.